Today's lesson, 11.2, found on page 439 of your book, is all about exploring surface area using nets. So what is the relationship between a net, the two-dimensional figure, the two-dimensional shape of a three-dimensional object? So what is the relationship between a net and the surface area of a prism? So in other words, we're going to take a rectangular prism, flatten it out like we did in the last couple of lessons, and figure out what the surface area of this, plus this, plus this, plus this, plus this, and this. What the whole, all of the surfaces of this three-dimensional object is. And we're going to do that by using nets. All right, the surface area of a solid figure is the sum of the areas of all the faces or surfaces of the figure. In other words, you take all of these surfaces and you add them all up. Surface area is measured in square units. You can use a net to help you find the surface area of a solid figure. Okay, so we need these materials: a centimeter grid paper, ruler, and scissors. A box is shaped like a rectangular prism. The box is 8 centimeters long, 6 centimeters wide, and 4 centimeters high. So this gift right here that's wrapped in the pretty paper, we want to find out how much pretty paper we need, basically, to cover all the surfaces of this box. So what is the surface area of the box? We're going to draw a net of the prism on centimeter grid paper. We're going to cut it out, fold it to confirm that it represents a rectangular prism, and finally count the grid squares on the face of the net to figure out what the surface area is. So I need 8 by 6 by 4. All right, so let's start with our 8. So we go, let's see, 1, 2, 3, 4, 5, 6, 7, 8. All right, so there I have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 8 centimeters long, now 6 centimeters wide. So we'll go 1, 2, 3, 4, 5, 6, and close up our rectangle here. And that's, we just drew this right here. So that's our first side, is 6 by 8. Now we need to draw this side here. That's 8 by 4. 8 inches this way, 4 inches tall, or centimeters, sorry, centimeters tall. Sorry, I'm saying the wrong word. Okay, so we have 8 here, so now we go 1, 2, 3, 4 by 8. So that's 4 by 8. This is 6 by 8. This is 4 by 8. Okay, so now we've got 2 sides. Now we need to do the bottom of the box, which is the same as the top, right? It's the same as this one. So we need another one of these because that represents what's going on underneath. That's sitting on the tabletop. And that was 6 by 8. This is 8, so I need to come down 6, 5, 6. Sketch that. 1, 2, 3, 4, 5, 6. Yep, so I've got another 6 by 8 for the bottom. This is the top, the bottom. This is one side. So now I need to do this side of the box, which is another 4 by 8, right? It's another one of these right here. Another 4 by 8 on the far side. So that would be 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. So I've got another 4 by 8. All right, So I have the top, the side, the bottom, the other side, but look, I still have this and the one on the back side that I have to draw. Okay, so, and that's 6 by 4. So I have 6 here, 1, 2, 3, 4, 5, 6 by 4. All right, and this is going to be the front, right here, the front part. And I need now the back, which is also 6 by 4. All right, now I have the back. And this is another side. So I have the top and bottom, the sides, and the front and the back. So now I need to count all the squares to figure out, pardon me, the surface area of wrapping paper I need to wrap my gift, right? Okay, so this is 6 by 8. So I've got 8 across and down 6. Isn't that 48? Isn't that what that equals? 6 times 4 is 48. Well, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So the top is 48 centimeters squared. The bottom's going to be the same. It's also 48 centimeters squared. So these two are done. We figured out those. How about our front and back? Well, this was what, 4 by 6? Isn't that 24? Let's double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Sure as heck is 24 centimeters squared. Okay, so we have 3 of our 6 sides done. Well, guess what? This is the same as that one. So this is also 24. Now we have to calculate the 2 sides, and we're done. Pretty close. So 4 times 8 is 32. Let's double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Sure enough. So, to calculate the surface area, all we have to do is add all of these up, and that will give us our surface area. So, we have 2 24s, we have 2 48s, and we have 2 32s. And add them all up. So what is that? 8 plus another 8 is 16, plus 8 more is 24, 26, 28. Regroup the 2. 2 plus 2 is 4, 6, 10, 14, 17, 20. So my final answer is 208 centimeters squared for this whole thing. 208 centimeters squared. So this is 208 centimeters squared. So our front was 24, back was also 24. This one was what, 32? Wait, yeah, 32. That one was also 32. This on top was 48, And the one on the bottom was also 48. That's how we calculated the surface area. You just find the area of all the sides and add them up. All right, so explain how you use the net to find the surface area of the box. Well, we just counted the grid square on each face, right? I counted the grid squares on each of the faces, then added them all together. All right, describe how you could find the area of each face of the prism without counting. Well, how can we do that without counting? Well, this is 6 by 8. I can just multiply it, right? 6 times 8. 4 times 6. 4 times 8. 6 times 4. 4 times 8. Okay, I can multiply the dimensions, right? I can find the product, which is the mathematical term for multiplying, right? I can find the product of the length and width of each face, which in the case of a rectangular prism is 6. 6 faces, right? Okay. All right, so we don't have to count them, which is essentially what? Area equals length times width. What do you know? We're still using that same formula. Or area equals base times height. They're interchangeable. They are the same. They'll give you the same product at the end. All right. Here we go. So you can also use the formula for the area of a rectangle to find the surface area of each box. I just said that. Area equals base times height. That's all they're saying. Find the surface area of the box in the investigate, which measures all those things. Okay, so label the rectangles in the net A through F, then label the dimensions. So the dimensions are going out here, it looks like. Okay, so D, I don't know where they want those dimensions. Okay, so this is 4 by 6. So this is a 4 here, I guess they're saying. This is a 6 by 8. This is a 6 by 4. Okay, I think I did that right. They're all centimeters. Just like those. All right, now we're going to find the area of each face of the prism. We're going to find the area of the rectangle by multiplying the rectangle's length times its width. Record the areas of the faces below. So face A is 4 times 8, which is 32. So this one's 32. 4 times 8. B is 4 times 6, which equals 24. So this one's 24. C is 8 times 6. 8 times 6, which is 48. D is 4 times 6, which is 24. E is 4 times 8, which is 32. And F is 8 times 6, which is, whoops, I'm sorry, 48. 48. All right, and that's another 48. Add the areas to find the surface area of the prism. We've done that. The surface area is 208. All right, so identify any prism faces that have equal areas. Well, A and E have equal areas, B and D have equal areas, C and F have equal areas. All right. How could you use that fact to simplify the process of finding the surface area of the prism? Here's multiplying by 2, right? Because there's 2 of each of them. So, so 2 faces have areas of 48 centimeters squared. 2 have areas of 32 centimeters squared. And finally, 2 have areas of 24 centimeters squared. That looks almost like a question mark. There we go. I could find this, so I could simply double 48, 32, and 24 and find the sum. So basically your stack of numbers that you're adding together, there's only 3 numbers instead of 6 when you're adding at the end. So it would look like this. Let's bring this back. So instead of 24 and 24, these together equal 48. 48 and 48 would be, what is that, 4 less than? That would be 96, because it's 4 less than 100 is what I did in my head. And 32 and 32 would be what, 64. So I only have a stack of 3 numbers to add up instead of 6. So then I would have what, 18, 1, 5, 14, 20, 208. I get the same number. Just makes your stack a little shorter. That's all you've done there. All right, so finally, describe how you could find the surface area of a cube. Well, that's even easier. You're just going to find the surface area of one side, then multiply by 6, because all 6 sides are exactly the same surface area on a cube. Let's see if I can find a cube here. So if I find the surface area of this one side, let's say it's 20, I'm just making that number up. Well, this is also 20, 20, 20, 20, and 20. All 6 sides are 20, so I just have to multiply by 6 when it's a cube, because all the sides are exactly the same. Alrighty. So you're basically doing the same thing here. Just find the surface area of each of these faces and add them together.